Thanks for joining me today, Tsahi. Let's talk about Simulcast and WebRTC. You blogged about this recently on bloggeek.me. And so similar to how you opened that blog post, I think it's important maybe before we start talking about the details of Simulcast, give our viewers a quick overview of the term bitrate, please, since that's going to factor into the conversation a lot.
Okay, so when you try to look at a video call, and there are multiple users in that call, you need to send data towards these users and receive data from them. Okay, now bitrate is limited, like any other resource that we have. Bitrate is highly limited, although we think that it isn't, but it is, especially the low latency kind. So we try to limit the amount of data that we send and receive. Okay, so let's say I need to send data to 4 participants, but one of them has a poor network or is on his phone. So he needs to get less bitrate than others. What should I do? Should I send everyone low bitrate because that's what this guy can handle? Should I decide not to send him video? He'll get only audio. Or should I try to send him something that would fit him and send others something that is of a higher quality? Now, the bigger the group, the more such issues with different limitations and capabilities of each user that I'm going to bump into and will need to solve. And that's, I think, where Simulcast comes in.
All right. So what so tell us about Simulcast. And Simulcast is, we're going to try and avoid those lowest common denominator situations, correct? Of that one person on the mobile connection, bad network. So how does it solve that?
So in WebRTC, we're trying to be as lazy as possible on the infrastructure side. And that means that we're trying to reduce our costs of running the service. So whatever we can offload towards the devices, we are going to do that because that means paying less for the service. Okay, as a service provider, I really don't care about your device. So what
buy bigger memory, it's your problem.
Yes, exactly. So it's not like if Netflix is going to send a movie to people, it's going to send it in different bit rates based on each user's device at home. They can do that because they have one movie and they need to stream it to 1 million users. And they do it offline. But with us, it's like, it's a call for people. I'm not going to spend my server performance for that. So what we're going to do is use Simulcast. And in Simulcast, each device is going to generate more than a single video stream for the same content. So let's say I'm in a call. I'm going to do a low bitrate video stream, let's say 150 kilobits per second. This one is for the mobile device. Then I'll do one at 500, 550 kilobits per second. Okay. And then I'll do the third one with the rest, 2 megabits per second. I'm going to send all these to a media server called an SFU, a selective forwarding unit. And now that server has a menu of different bit rates to choose from and to send to each and every participant based on the needs of each and every participant. These needs can include how much bandwidth that user has, how much CPU it has available to decode all of that data, what is the screen resolution. I don't want to waste high bit rates and resolutions on small screens, for example, not worth it. And even what layout is being displayed. Different people might view the same meeting in a different layout and different way. So again, the layout is going to define what resolutions they actually see things. And again, I don't want to send higher resolutions than what is being displayed because that's wasteful and we don't like waste.
Yeah, absolutely. Now you mentioned SFUs in there. Simulcast only works with an SFU media server, correct? With an MCU, it would at least work differently, right? I mean, you're not allowing any change on the client side.
Let's do two things. First of all, there is an MCU and an SFU. An MCU is for those that can work with expensive backend equipment where all of the encoding, decoding, compression, mixing can be done on a server. That's like the old guard of how you do things, or when you need to record things and stream it live or broadcast it into YouTube Live or whatever. Then use something like an MCU, a mixer. There you don't use Simulcast because you don't need Simulcast. Okay. There's an SFU that routes the media around. Usually you have Simulcast there. Almost by default today, it's quite common. And SFUs are the most common media servers in WebRTC. The reason I was like, not exactly, is because I am sure that there are use cases where you use a different type of a server that is an SFU but is not called an SFU that you can use and do use Simulcast with.
Fair
Okay,
enough.
so I don't want to be that only SFUs.
We want this recording to last, this conversation to last for on. Maybe someday tomorrow somebody's going to invent something else. But
Yep.
no, yeah, definitely one of the reasons, one of the benefits that you get of using SFUs, why they're predominant media server architecture to use. Now, you talked primarily about the need for the different bit rates and handling the different resolutions in like low network conditions, like somebody on a mobile network. You hinted at, but let's talk a little bit more about use cases where you might intentionally use a lower bit rate on some streams, regardless of the quantity of bandwidth available, right? So thinking, things like video thumbnails for the person who's not speaking is one, I know.
So I think, let's say that I want to share something in this meeting, in this thing that we're doing. I'm going to share my screen, and the moment that I do that, we're going to be small thumbnails next to that video, okay, somewhere on that side. Now, once that happens, I don't really want to send high bitrate to the people that are going to watch it that way. Because if I send that at a high bitrate and everything is high bitrate, I need to first send more data. Let's say I've got that data, but now I need to decode two high resolution videos, where one of them, after I decode everything, I'm going to scale it down. So I'm going to spend more energy sending it, more energy receiving it, more energy decoding more bits, and then more energy because I need to scale it down. Okay, so this is one instance where I don't want to do that. The other one is, let's say that we're watching this on a smartphone. Now, I don't know about you, but mine is like 5-inch, 6-inch, whatever. Okay, you can put 1080p here. That's fine. You can do that. I can't see 1080p on this kind of a device. I won't notice the difference between that to 780p, and probably not with VGA.
Yeah.
Done with good enough bitrate. So this being the case, again, I won't spend too much effort on that device. So it's not only resolution, it's also screen size. Then there's the matter of how important the video is. Let's say it's a large classroom. We have 30, 40 students in that classroom and one teacher. Guess who's going to get all the bitrate?
The teacher. Yeah, exactly. Who's the focus of this meeting, of this conversation?
Let's say that someone is raising his hand and asking a question. We're going to give him more bitrate for that part of the call, but then we're going to take it away from him. And we're going to do that by checking audio volumes or your hand raising in the application or whatever. Different ways of doing the same thing. But at the end of the day, I need that flexibility, that original menu of I've got different bit rates and I use different ones to different users in that scenario, and I switch in between them dynamically as well.
Now, talk about are there switching costs of doing that sort of thing on either the server or the client side, depending on where it's being done?
Everywhere. So first of all, let's go to the fact of let's start with the naive approach. I send 3 different bit rates. Usually Simulcast is 3 layers, low, medium, high. I'm going to send all 3 of them. Now let's say that I'm a shy guy and I'm muted in the call. So if nobody sees me, I might not even need to send the media to the server. Okay, and that is going to be very, very beneficial to everyone. Or I might only decide to send the lowest tier of bitrate. Let's say that all of us have a great network. I might end up sending only the highest bitrate of one of the users to everyone all the time, and I can forego using the others, or I can keep the medium one if I need to go down because of packet losses of someone or something like that. So there are different strategies of saying, well, if nobody is watching, don't send it. That's one approach that you can take. The other one is if you look at the server, okay, it now has a lot of things that it can look at and decide what to send to whom. And again, that menu of choices is something that it can optimize with, but in order to make that decision, he needs to understand what happens on the clients, and he needs to be aware of the application itself. So I need to know what is the layout of each one of the users, what they see on the screen, and which videos are important and which ones aren't. And this is application logic. So for me, an SFU is a big kind of a building block that adds flexibility into the solution.
Mhm. Absolutely. All right. Well, Sahi, there's a lot we could talk about in this. We're kind of at the end of our time now, but what's interesting to me about this conversation is how much it touches on like the media server architecture, the application logic, as you were just saying, as well as the user interface design and how you interact with it. Do you, as the individual client, have the ability to change your layout versus only, say, the teacher in that classroom scenario? So this affects a lot of different use cases and things you need to think about when designing your application, but Simulcast enables that, SFUs enable that. So there's a lot here to learn. So where can our viewers go to learn more about topics like Simulcast? I know you have a lot of courses and do a lot of great blog posts.
So there is bloggeek.me where the post is there. There is more information there. There is WebRTCcourse.com where I have my courses. And then just search it on the web. There is a lot of resources there, some better than others. But just go and search. The data is out there.
There is a lot out there, and certainly your content comes up pretty high whenever you're searching any of these terms. So we appreciate you sharing the expertise with us, as always, Tsahi. To learn more about Tsahi's work, as he said, and sign up for his courses, you can start by checking out bloggeek.me. To learn more about future episodes of WebRTC Live, visit us at webrtc.ventures. Thanks for joining me, Tsahi.
Thanks, Arin.